And now for section 2.5 on acidic and basic solutions, pH, and buffers. First, we'll continue our discussion about water. This is a neutral solvent, and it spontaneously dissociates to form ions. So we could see this taking place on the right-hand side here. The bond between oxygen and hydrogen breaks apart spontaneously, and 1 in 10 million ions per liter can be found. And our hydroxide group is termed the hydroxide ion, and you could see it's represented here by the OH negative. And our other ion is going to be our hydrogen ion, and that could be represented by the H positive. That's because we pulled that electron over to our hydroxide ion, so we have a negative charge here, leaving our hydrogen positive. Sometimes we can have that hydrogen ion transferred to a second water molecule. So here we see our water molecule and our hydrogen ion. And now we have our hydronium ion, which is H3O positive. And as we go through these reactions, we have to have an equal number of positive hydrogen ions with negative hydroxyl ions. So here you see these two water molecules have gone through a reaction, producing a hydronium ion and a hydroxide ion. But we can, of course, simplify this to this chemical reaction. Now let's move into our acids and bases. Acids are going to dissociate in water to produce hydrogen ions and an anion. So they are proton donors. They are helping to increase the concentration of free hydrogens. And the more dissociation we have of those hydrogen ions, we will have stronger acids. For example, we have hydrochloric acid within our stomach that would dissociate into a chloride ion and a hydrogen ion. When we have less dissociation of hydrogen, it forms weaker acids. And an example of this would be carbonic acid within our blood. And you could see the dissociation that would take place over here. When we take a look at the bases, they are going to be the ones that accept that hydrogen when added to a certain solution. So they are known as being proton acceptors, and they will decrease the concentration of free hydrogen ions. The more absorption we have of the hydrogen ions, that means we have stronger bases. And examples would be like ammonia and bleach. So here we see that ammonia, which is our base or our proton acceptor, mixes with water, and now it has taken that hydrogen from the water molecule, and we have formed an ammonium ion, and the solution itself has become a basic solution. And the less absorption of hydrogen ions we have will become weaker bases. This would be like bicarbonate within our blood in the secretions released to the small intestines. If you think about some of the digestive system, anatomy, and physiology that you know already, the solution within our stomach is very acidic. So as we move into the small intestines, we need to reduce that acidity, and it does that by using bicarbonate. And now for pH. pH is going to be a measure of hydrogen ions. We look at the relative amount of hydrogen ions in a solution, and there's a range between 0 and 14. pH and the hydrogen ion concentration are inversely related. So the inverse of the log for a given hydrogen concentration that we see here on the left can be represented by this pH value here on the right. And as the hydrogen ion concentration increases, the pH decreases. So you could see our more acidic components are here in the red region, whereas as the hydrogen ion concentration decreases, the pH is going to increase. So we see this over in the blue phase of our pH scale. And when we have solutions with equal concentrations of hydrogen ions and hydroxide ions, they are going to be neutral and have a pH of 7. Solutions with greater hydrogen concentration than hydroxide ions would be acidic, like we mentioned in the previous slide. So we could see this over here. They have a pH less than 7. And solutions with greater hydroxide ion concentration than hydrogen ion are basic or alkaline, and they're going to have a pH greater than 7. Moving from one increment to the next is showing a 10-fold change. For example, if we look at something that has a pH of 6, this has 10 times of a greater concentration in hydroxide ions than water. And now for neutralization. This is when an acidic or basic solution is returned to neutral. Acids are neutralized by adding bases to them. So these would be things like medications in order to neutralize stomach acid, in which they contain a base. And bases can be neutralized by adding an acid. We also have buffers within our body, and they're going to help prevent pH changes if excess acid or a base is added to that solution. They can act to accept a hydrogen ion from excess acid or donate a hydrogen ion to neutralize the base. And molecules that help, or a molecule that helps to do this, is carbonic acid. This is a weak acid, and there's also our bicarbonate, which is a weak base. And this helps to buffer the blood pH within our body so that our blood doesn't become too acidic or too basic, and stay within that critical range of 7.35 to 7.45.